Now based on that, we have a set of very easy ICSE concept builder examples, which are nothing but the numericals based on this phenomena of echo. Remember, these numericals based on echo are very important from ICSE point of view, and they are very easy as well. So let us take a look at the very first concept builder example, which says that a man claps hard and hears the echo of the sound created from a distant wall at the end of 2 seconds. So time t is equal to 2 seconds in this case. So the man claps and he happens to hear the echo after reflection from a wall at a certain distance at the end of 2 seconds. What is the distance d of the wall from the man, considering the speed of sound in air is 340 meters per second? So we know v is equal to 340 meters per second, and we are asked to calculate the distance d. So let us club the given data. Distance d of the man from the wall is represented by small d, and the time taken by the sound to reflect back is 2 seconds. And to be able to calculate this distance d, we need to consider that to hear an echo, the total distance traveled by the sound and back is d in the forward direction and d in the backward direction after reflection, which is d plus d, which is nothing but 2d. So we know the formula: speed of sound, speed is equal to total distance traveled upon total time taken. The total distance traveled is 2d. d becomes v into t upon 2. The time t we know is 2 seconds, and the velocity v is given to be 340 meters per second. So 340 into 2 upon 2 is 340 meters, and hence we can say the distance between the man and the wall d is equal to 340 meters. So that answers your question. So as easy as that. Now we have a question on ICSE 2013 based on this forward 2 marks. Remember, this is a very scoring question. It is exactly similar to the example that we've seen. It says an observer stands at a certain distance away from a cliff and produces a loud sound. He hears the echo of the sound after 1.8 seconds. So time t is equal to 1.8 seconds, and we are asked to calculate the distance between the cliff and the observer if the velocity of sound in air is given to be 340 meters per second. Here again we need to calculate the distance d. Now let us club the given data. The speed of the sound is given to be 340 meters. Time taken by the sound to get reflected back is 1.8 seconds, and let the distance of the man from the wall be represented by small d. We know that to hear an echo, the total distance traveled by the sound and reflecting back would be d plus d, which is 2d, and hence substituting in the formula, we know the formula that speed of sound is equal to total distance traveled upon total time taken. The total time taken being represented by t. So v is equal to 2d upon t, and thus the distance becomes d is equal to v into t upon 2, and substituting the values, we get 340 into 1.8 upon 2, which is nothing but 306 meters. So this becomes your final answer, and this is going to fetch you 2 marks straight away for a question asked in ICSE 2030. Remember to write down your final statement. It always impresses the examiner. Say, hence the distance between the cliff and the observer is 306 meters. So this will definitely fetch you 2 marks straight away for such a question asked in ICSE 2013. Now again we have a very similar example from ICSE 2009 forward 2 marks again, which says calculate the minimum distance at which a person should stand in front of the reflecting surface so that he can hear a distant echo. Now what do you understand by minimum distance? This is a keyword over here. Notice that over here you are not given the value of time t. You are only given the speed of sound in air as 350 meters per second. You need to calculate the distance d, and unlike the other two examples, you are not given the time t. So how would you know what value of time t is to be taken? So for that, identify this keyword over here which says minimum distance. This minimum is a keyword over here. It simply means that we need to take the minimum value of time t, which is nothing but the time for which a certain sound persists in the ear, the minimum time, which is nothing but 0.1 second. So always whenever you see the word minimum distance in the question, remember you need to take the time t is equal to 0.1 second, which is the minimum value of the time possible to be able to clearly or distinctly hear an echo. So let us club the given data. We are given the speed of sound in air is 350 meters per second, and to hear an echo, the total distance traveled by the sound and on reflecting back would be d plus d, which is nothing but 2d. Substituting in the formula, speed of sound is equal to total distance traveled upon total time taken, which is nothing but 2d upon t. Substitute the value of time t is equal to 0.1 second. We get v is equal to velocity into time upon 2, which is nothing but 350 into time being 0.1. So 350 into 0.1 upon 2, which is nothing but 17.5 meters. And you can thus write the final statement as the minimum distance at which a person should stand in front of the reflecting surface is 17.5 meters to fetch you 2 straight full marks for such a question asked in ICSE 2009. So a very important question indeed.